Let's see. So you have one.
I have two of the DH 200s.
And then if you want to get a third one, you're going to have to get something a little heavier duty. Okay. So you don't have two of these.
Hello everybody, we are live on YouTube as usual. It's that time of the day where we talk about random things to do with astrophotography. So this time around I thought we'd do something a little bit different that is not like strictly astro related, but obviously we're doing astrophotography, so what would be a good idea? Well, DSLRs are all been covered to death as far as I know. Everybody who has tried it has done it. Big question here is who uses what, where and when. So what we're going to do today is we're going to check out some of these mirrorless cameras. I have an audience. Hello.
Hi.
And we're going to basically start from what is good, what is not good, things to look out for, and basically some of the functionalities behind them. So let's make a start on something a little smaller, more affordable, and definitely works, because I actually have the counterpart version of this. So this is the Canon M series. There was a M3, M5, the M6, the M7. I had the M3. This is the newer version of this camera. This is the M50. They have an M100. And the big thing about this is focusing. I mean, God, was it a pain in the butt to try and focus with a DSLR camera until Canon came up with the swivel tilt screen, and it can go in just about any angle imaginable, possible to man. And it made focusing a lot easier. And all these DSLR and mirrorless style cameras have a zoom function. And if you're using something like a Bahtinov mask, they work incredibly well. In terms of performance for astrophotography, these are actually pretty damn good. In fact, they're actually based off of the Canon Rebel series cameras. It's the same sensors, same everything. The software that drives the camera is essentially the same thing. That made these actually pretty useful. By default, they don't have like an intervalometer functionality built into them, so you kind of had to go out of your way and buy something. You could use the software, of course, the Canon EOS utility, but one big thing about this was you can connect with your phone. That's your smartphone or a tablet device. You just download the software and you can actually have a live view and tap and take all the pictures, set your ISO. The only thing you can't do is your focus, obviously. So, that's one thing about one of these cameras that actually make a big difference. So that's the M series from Canon. They have right now the M100 and the M50, the M100 being the cheaper of the two. In terms of performance for Milky Way shots, like wide angle, I mean this is a 22mm, so it's pretty damn wide. It's not the best. Biggest problem here with Canon smaller cameras is their ISO sensitivity. It's good for what it is, but it just doesn't really perform quite as as detailed or as good as it would do, as you would want it to do in low light. So that's kind of where this one falls apart a little bit. But when you're doing like astrophotography just in general through a telescope, this thing is a pretty good buy from a mirrorless market. Next up within the Canon line, so we're going to work through all the different cameras, Canon, Nikon and all that. Next one in the line from Canon is the RP, and this one has the adapter to fit regular EF lenses. The useful thing about this though is if you do get this camera with the actual adapter, I'll take the lens off. So it's basically this here, you can attach any Canon T-ring to it. So if you already have an existing Canon T-ring, it automatically connects onto there pretty much, and then you just put your nose piece straight into your telescope and you're good to go. Functionality wise, it's very similar to the M series from Canon. Now this is the RP version. The big problem with the RP version is a lot of the functionality, it tends to be a little bit buried into all the menus, and it can be difficult to access on the camera physically. So you're navigating all the dials and you're pressing the buttons in the back, and it can be quite cumbersome in comparison to something like a 5D Mark whatever, if you're used to that type of stuff, because you kind of want the ability to do all the manual functionality and stuff like that, because that's what it's all about, you know, manual focus, the whole 9 yards. Again, has the zoom feature where you can zoom into the star and make sure it's in, you know, perfect focus. Again, Bahtinov mask will help you out there tremendously. Next up is the Eos R. This basically is a 5D Mark IV with a bunch of stuff stripped out of it, namely the mirror, you know, the thing that flaps up and down. The good thing about this is this does allow for complete, fully manual mode, and again, it still comes with the tilt flip screen. So, you know, when you're in that awkward area and you're trying to figure out where your focus is, or you don't have to learn how to contort yourself like some people, you know, it's a lot easier. Again, both these cameras, the RP and the R, you can actually control them with your phone with the Eos utility. Hello, Kevin. You haven't missed anything. You can just wind it back. You didn't miss much. I was just talking about this one here, the M50, this little baby here. If you have any questions, save it when I'm done jabbering. Next up, Nikon. Nikon has the Z series. They have the Z6 and the Z7. Most people will actually turn around and say, give the Z7 a miss, but go straight for the Z6. The Z6, interestingly enough, has such a big area here. So here's the big problem with these cameras, similar to the Canon. I'm going to show you that as well. It's okay, these are demo cameras, so I can dirty them up, drop them, or whatever I want to do to them. Well, don't want to drop them, so I break it, you buy it. So it gives you an idea of how big these sensors have gotten and how much. This one's got the mechanical shutter on it. The big problem here is with these newer cameras is you have to have an image circle that can illuminate the entire sensor. So you have to be careful. Whereas APS-C, you can easily use, by the way, that's APS-C, you can use 1.25 inches when you're doing full frame. The 2-inch nose piece is now becoming extremely critical. Your back focus now has to be recalculated. Again, if you get the RP or the Eos R and it comes with the ring adapter, which is this thing here that allows you to plug into EF lenses, that already has the back focus distance worked out for you, so you don't have to figure anything out. You put the T-ring onto it, then you put a 2-inch nose piece and boop, straight in the telescope, and you're good to go. These aren't really ideal for inch. So far, there aren't any T1. A couple of people that have aftermarket versions, be very, very careful with those ones because they're not true tried and tested thing yet. So some of the parts may not be as useful. Did the stream stop? I hope not. So if you can't hear me, we're in trouble.
Can't hear you.
God, I hope not, because I've just been going. Next up in the mirrorless market is Sony. Sony has a whole bunch of cameras that are pretty much the same thing here. This one particular is the A7 III. They have the A7S II. I'm not going to tell you this, but A7S III might be coming out sooner or later. No, you didn't hear that from me. But on the A7R3, the differences between those cameras is basically higher resolution. Now, there is a slight drawback. You shouldn't really use the Sony cameras for doing this because Sony cameras have a very unique noise reduction algorithm that actually is known to remove stars. So if you try to plate solve, the plate will actually fail because it will go, well, this star ain't here, so I can't be looking there, and it won't find it in general. But normally, if you're doing like Milky Way shots and things like that, Sony actually has the competitive edge by a long shot over the other cameras because of its ISO sensitivity, and that noise reduction algorithm makes your images a little bit smoother. You can go all the way up to 6400 ISO, even beyond that, and still have some really stunning results. If you don't have a tracking, remember to always apply the rule of 500. I'm sure you can Google that as much as you want to get the exact numbers. Some people do the rule of 300. It makes no difference. You know, it's all the same principle. On average, If you have a 14mm lens, you can do a 10-second exposure without any trouble. There'd be a tiny bit of star trailing, but you know, who's looking? Next up in line, and a lot of people disregard Fuji. Fuji actually has APS-C crop sensor, in other words, size cameras. The reality is their system is actually very unique to them. They have the X-Trend system for their image processor. Here's the interesting thing about this. With Fuji system, if you're shooting JPEG, you can do the different color profiles. So what happens here is if I do the film simulation mode and I pick a film simulation like Velvia, for example, or even Provia by default, you can actually get colors to be really punchy and nice, but that's only in JPEG. RAW, not so much. One of the biggest problems behind Fuji's system when you're doing astrophotography in general is they add this level of grain into the image because they have this film emulation mode, and you just simply cannot turn it off. The only way you can turn it off is to actually buy the software or to download some of the software that doesn't include that noise algorithm, but you have to shoot in RAW with the Fuji system. Now, if you check out my Instagram, if you haven't already followed my Instagram, it's Simon2940, and that's on Instagram. I actually use the Fuji GFX system to do astrophotography using a Borg 90. The thing about that was it's a medium format camera, which makes it very wide field, but the dynamic range on a Fuji camera compared to all of the others is by far and wide the best. So sometimes where you kind of fall out on, especially with the artificial noise insertion, you regain some of that stuff with just the dynamic range and the richness of color. And it's quite amazing that even with 30-second exposures, you can get some absolutely stunning results. Now, in terms of which camera produces the best type of coloration, other than the Fuji one, Sony probably is the worst. It's very muted colors, very flat looking. So if you're after that crazy punchy look that you would get from the Milky Way, I don't suggest doing the Sony route. If you're already tied into one particular system because of the lenses that you currently own, you know, it can be a bit of a challenge. So if you don't own Canon, the M50 may be the better option if that was the case, because at least, or even the M100, because at least that way you are not spending or getting into something for a lot of money. And of course, if you already are a Canon user with the EF-M or the EOS M adapter to EF lenses, you can use any of the EF lenses in its entire range, which, you know, can be quite useful. By default though, these EOS M lenses are not particularly good for astrophotography purposes. The aperture, and when we say aperture, we're really talking about the front element aperture, is just too damn small. So when you get something like this, you kind of want to get like a 14mm wide. Don't forget to include the crop factor, because you have to figure that out as well. It's times 1.6 for those of you who don't know. The 14mm gives you the best performance from the Canon EF line because it is a larger aperture. Most people who like to cut a few corners here and there like to use the Rokinon version. Personally, I find the Rokinon lenses a little bit soft. They're great for doing video or filmic look, but they're not as useful when it comes down to astrophotography. This is the Cine DS line that I'm referring to. They do have a photography version with the clicking aperture. Again, you kind of want to do the DS line for one specific reason. It's what they call declick. There is no clicks on the aperture. So the idea here is, in order to combat coma, I can dial the aperture exactly where I want it to try and alleviate coma. I'm not worried about the lens flare. I'm not worried about the diffraction spikes coming from the actual aperture leaves that go through. That sometimes is quite appealing to me. I like that diffraction, but what I don't care for is coma. You know, who does care for coma? Moving back to the side here, Nikon actually is known for a lot of their astrophotography functionality. Nikon had the D810A at one point. It was almost unheard of in the astrophotography market for them to release a DSLR style camera, high end, because there's the D810 back in its time was the flagship, which is now the D850. It was unheard of for them to release something like that. Canon did something with the 60DA, but the 60DA was actually made as an inexpensive alternative, but they didn't give you full frame, whereas the Nikon D810A is a full frame. They carried that over, and interestingly enough, a lot of people don't realize this, but the sensors that you get in these guys are actually from Sony. They're Sony cameras, for lack of a better description. It's just their sensor that they buy into. But the big part of it here is they don't have their noise reduction, their noise reduction algorithm. They have their own unique algorithm. They tend to be a little bit more faithful when it comes down to raw shooting methods, and a lot of the new telescope manufacturers who create all these astrophotography strict systems have actually looked at the Z6 and have adopted the Z6 methodology. Why? If you look at ZWO, QHY, any of these big CMOS camera manufacturers, they have a lot of the cameras are actually from a Sony, so from a Nikon camera, like the D5600. They even have it from their 810. Hold on 1 second, I'm going to grab that phone. Yeah, they grabbed it. So we are live, so I am sitting in a store. This place can go a little bit crazy, and I forgot to turn that phone down, so if it's distracting I will stop. And if you're watching the video, fast forward. If the phone rings, not when I'm talking preferably. So going back to the Nikon, they do pay attention to the astrophotographer. They are aware how big of a market it can be. They are aware that people do buy things specifically for one particular purpose. So that's where Nikon really have excelled when it comes down to this. Obviously Sony being Sony, that's not their MO. Their thing is video, always has been, always will be. One of the things that I would turn around and say, there's a mosquito. Sorry, got bugs in here. One of the things that does have a big advantage on some of the higher end Sony cameras is the high frame rate. So if you were doing live shots of, say, the moon and you wanted to stack afterwards, their video conversion and their compression is pretty damn good. So it's not heavily compressed, because you can pick the actual bit rate. So you can do what is known as intra-frame rates, which is one of the higher end settings. It tends to be at least 100 megabits per second, 100 megabytes per second. So you have to have a card, or an SD card, should I say, that is capable of writing at that speed, because that is, critical at the end of the day. When you're doing stills, it doesn't matter. If you're using the Fuji GFX system, not this particular one, but the GFX in general, it actually has a time-lapse or intervalometer mode. I'm not sure if Nikon implemented that in their recent firmware, but Fuji now has it by default. It's a bit of a hidden feature and a hidden gem buried inside of the menu, but it is well worth looking for. What basically this allows you to do is simply bypass using your phone or some kind of a clicker or anything like that. You just simply have the camera plugged in, go into the menu function, and you actually select intervalometer. You tell it how long you want it to expose for, and typical with Fuji in their bulb mode, you can actually pick the time, not have your finger on it. So I can say, no, I want it to be open for 2 minutes, and you can program it to do 2 minutes. It will do it. And then you say, I want 25 shots. Of course you have to set your ISO and all that kind of stuff, and off it goes. And you can just leave it for however long you need to leave it for. You can even tell it to shoot with a delay, because you don't want it to go bang, 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 one after the other, because obviously you get that kind of flapping and that motion or whatever it may be, and there might be a tiny bit of vibration, or you want some time for it to recover. So you can always set it to, whatever delay you want. You can have it a minute delay, you can have an hour delay. So if you were doing, I don't know, the eclipse, we'll just say that, you can set it to take a picture every minute, and you can do this one big crazy time lapse. So that goes with that. Any questions before I keep rattling on, because I will just talk forever? Anybody? I know there's 3 of you here. Did you have questions? Maybe, yes, no? Live chats. Nope. Okay. So let's go into some of the lenses with the mirrorless system. Now, I'm not going to talk about DSLR right now. I think that's kind of been done to death. You have to understand the market is now slowly but surely shifting towards mirrorless. And one of the biggest advantage about mirrorless is physical size and physical weight. I mean, these things that I have in my hands, and they are literally light compared to any kind of DSLR camera. I think the lightest in its weight class without the lens is actually the Sony. It just doesn't weigh a damn thing. The only drawback to the Sony and Fuji system is getting hold of the T-rings. They are a little trickier to come by. We do stock the Sony ones. We have the Pentax K-mount. We have the Eos M1. The only one we don't have right now is the Fuji, because the Fuji ones are the hardest to get a hold of. The GFX ring mount, T-mount, is actually quite widely available, strangely enough. You can normally get those on a Borg scope. Borg is a telescope, in case you're wondering. But they are quite widely available, very, very easy to adapt. It's the back focus that is critical, and you just kind of, you've really got to pay attention to the scope. You need to make sure that something like the GFX has the back end, the aperture, the actual imaging circle big enough to fit a medium format, because medium format is really, really big. I'm going to go turn that phone down, so just give me 1 minute. So I'm just going to disconnect myself, so enjoy the brief silence. All right. And that's one problem about doing live stuff is, it's live at the end of the day, and we're that prepared, not. Okay, so going back to lenses, I get asked all the time when people come flying into the store and they say, I want to take Milky Way shots, what's the best lens to use? Easiest way to answer that question really is to do with how much money do you really want to spend and how much you want to get into all of this, because sometimes I get people who see something and go, that's what I want to do. Now, if you bought any of the kit versions of a camera and you've got their kit lenses, the 18 to 55, it doesn't matter if it's a Nikon or a Canon or even the Fuji one, Sony's kit lens is slightly different. Believe it or not, by default, those lenses are actually great just to get started. You kind of want to go as wide as possible, and you just want to open up that aperture as much as you possibly can. You're going to be shooting at, depending on which camera you're using, 3200 ISO to 6400 ISO. You're going to expose for anywhere between 15 to 20 seconds on average. The longer it is, the better it is, but the more likely you are going to start the star trail. But that's at its widest setting. Light pollution can be a bit of a problem when you're dealing with stuff like that, and coma can also be an issue, because obviously the kit lenses and the less expensive or cheapy lenses, I like to refer to them as, they do have coma. You can kind of tell because of the aspherical shape of the actual front element. You kind of look at the lenses. In fact, I can almost demo it with this one here. So what happens here is you can kind of see how that asphericalness looks like, and you can see that weird bulbous look. Well, the problem here with these types of lenses is they don't necessarily create the flat field in the right place. And when you open up to say like f2.8 or even bigger than that, you're going to find yourself getting coma. A lot of these lenses were originally designed to have to be able to shoot architecture, landscape, that kind of stuff, where you have a horizon and you're setting that horizon and it's assuming that it's dead center. Well, the problem here is nobody shoots the Milky Way dead center. It only kind of spikes up that direction or over there. So you get this weird bowing effect. And the problem here is as that bow effect happens, coma occurs on the edges. So as you see the edges of the screen here, in these corners especially, the stars kind of smear and go round, and it's really, it's really evident in basically lenses that are not made for that type of correction. Now, the best performing lenses out there are actually made by Sigma and Tamron. Sigma has the Art series and Tamron has their prime lenses. Again, you want to go as wide as possible, you know, like the 14 millimeters and prime fixed, because they have been designed to have as much of that distortion removed as possible. Now, I would probably favor Tamron over any other when it comes down to their wide lenses, just for one sole reason: is there is no barrel distortion. That is their thing. That's what they spend their time on fixing, making sure they don't have those types of distortion. And by far and wide, you know, I love Tamron stuff to death, but I think some of their prime lenses, when it comes down to astrophotography, is just absolutely like spot on. Sigma, I would say, comes in at a second in comparison to all the other choices that you can possibly have out there. Again, with all the prime lenses, I actually find that their 85 is one of the better performers. Zoom lens wise, however, though, their 12 to 24 that Sigma has is actually really good for astrophotography purposes, but you've got to be careful where you have the horizon, because again, it will start to fisheye. Again, these are all designed for like full frame cameras, so with a crop sensor it acts more like an 18 than anything else. Fuji, on the other hand, is a bit of a dark horse in all of these. We do not make bad lenses. I mean, there are almost no exceptions. The XC line tends to be their budget conscious end lenses. The only thing that they basically cheap out on is functionality. The glass is actually still the same. That's one thing Fuji doesn't do, is cheap out on their glass. That's to me is a critical thing. What that basically translates to is, depending on how much of the Milky Way you're trying to see, any of their lenses work. Even the standard 18 to 55 that they have actually produces phenomenal edge-to-edge results when it comes down to it. Very, very little coma, if none at all. And you know, if you do start to feel that coma is becoming a problem, drop down to an f5.6 and then you can go from there, and you'll actually find it gives you quite a big improvement. But instinctively, if you're going to be using something like their wide angle lenses that they have, they got a 27, which is absolutely fantastic. It acts more like a 35 millimeter though. They have a 14 as well. That at f4 is probably one of the best lenses I've seen for astrophotography purposes. It's just fantastic. Canon's lenses by default, I'm not a big fan of Canon glass specifically for astrophotography. There is a tiny bit of color, false color to it. You got to understand that Canon makes lenses or makes glass for terrestrial purposes. It's all color corrected for terrestrial. It's designed to work with light. Whereas, you know, when you shoot astrophotography, there ain't no light. You're literally looking at dots in the sky. So you're very limited to what you can and can't get. Even with the L series lenses, you do get a tiny, tiny bit of fringing, and it's, you know, just a touch of false color. It's not like, oh my God, earth shattering, but you know, it's very evident when you use something like the 70 to 200 L series. I've noticed that it just does not look as good as I would do with some of the high-end refractors like a quad or even a triplet refractor. In fact, if I'm at that type of focal length, I wouldn't use, you know, a regular zoom lens. It just doesn't make sense, considering that a small scope, a 65 millimeter, a 72, they are actually cheaper than buying a 70 to 200 in any fashion. Yes, I understand you get the added bonus of the f2.8, but you're never going to shoot 2.8. You just simply can't. You just have too many weird problems, aberrations. And for those people who have tried it before, you'll understand what I mean. You know, the stars on the edge will just coma like there is no tomorrow. When Canon and Nikon in their mirrorless market, in other words, the Eos R, oh my God, there's too many letters. The Eos R and the Nikon Z series, when they release their native telephoto lenses, especially the 135, because of the way they're designed and the short flange distance, the flange distance is what I'm referring to, is the sensor how close it is to this top part up here. Because it can be so much closer, in terms of performance, they tend to only be at f4 is the so-called equivalent. If you were to use like a regular lens in its class, it's actually closer to f3.5. But what you're finding here is the resolving capability, because their aperture is measured at the rear element, now becomes better than what you would do with, say, a standard EF or EFS lens. So when they have those native focal lengths coming out, especially their 135, from an astrophotography standpoint, it's a bit more beyond wide field, but it is gonna be really, really good. And you know, quite honestly, a lot of people are waiting for that particular lens to come out so they can do things like that. Telephoto lenses just don't tend to be very popular, so it's a bit of a dark horse here, and it's still early days, so we've got a long, long way to wait. Questions? There's got to be questions. Been talking for ages.
I really don't. Yeah, I don't have a lot of stuff anymore.
I've got 4 people watching. Do I really have 4 people? Roll call. Hello, hello, hello. Can you hear me? Is anybody home? I'm just gonna check up and make sure you guys can hear me. Yeah, okay, good. Oh, hello, Craig. Welcome to the live stream. If you've got any questions or anything like that. Hello, Kevin, welcome back. If you guys got any questions. Questions, feel free, just fire them off. No bars hold or holds barred or hold bar hold. No? Of course, you can always check out some of our other videos that we've done in the past. These are the live videos that we've started to do, where we want to try and interact with some of you guys a little bit more. Because we're not always responsive on Instagram and things like that. So here's your chance to try and grab us, because you can see, we are in the store. It can be quite hectic in here. I know Daniel is trying to do his side of his videos on a Wednesday. He's been doing that through Facebook Live, I believe, as well. Can you send out an email a day in advance instead of just when you start and topic of video? Yes, we will be doing that. It's just at the moment, this is all kind of like we're just testing things, because we're actually going to be buying a bunch of equipment to be able to do this, and we're really just testing out the waters to see how good or bad this does. Of course, the video itself will be on YouTube, so you can watch it at a later time, because not everybody is going to be around. And again, don't feel pressured that you have to ask a question now. You can ask a question later, and I can address it as and when they come. So for us, this is still quite highly experimental, and it's been good. I enjoy it to a certain extent, except when it gets busy in here, and then I'm going like a madman. So yes. We will do that. We will tell people in advance. In fact, if you haven't subscribed and clicked on that little bell icon and all that kind of stuff, I highly recommend you do, because it does give you a warning, at least, of some description. How well does a DSLR compare to a dedicated camera working with a telescope? So I'm going to assume that you're referring to astronomy cameras. It's a bit of a strange comparison. I don't really compare the two for two sole purposes. DSLR mirrorless cameras are, at the end of the day, designed for terrestrial use. In other words, they're made to take regular daytime photography under ideal lighting conditions. Whereas astrophotography cameras like CWO, as you can see behind me, and Attic over here, there was QHY here somewhere, but as you can see, we've actually sold out quite a few of them. Oh, look, there's one over there. There you go. There's a QHY right here, the QHY 10 actually, to be exact. Cameras like that are, remember, they are designed to do astrophotography. They've had the filters removed. They have had modification. In fact, one of the biggest things that, I'm glad you asked me this now, one of the biggest things about a astrophotography driven camera or a DSLR or a mirrorless is what they mean by RAW. RAW is treated differently on something like this as opposed to the cameras behind me. When you pull a RAW image from any of these cameras, there is actually a level of processing that occurs. Fuji is actually a little bit more obvious because they actually apply a grain to all of their images, regardless if you want it or not. There is a way to turn it off in some of the more advanced programs out there like Capture One, but we'll go in that another time. Whereas shots from a Astro camera, like we'll say the 1600, the ASI 1600, what happens here is the picture that gets pulled down has no processing done to it. There is no dark, there's no calibration, there's no flats, no nothing. None of that has been done. It relies on you, the user, to actually do it for you. Whereas when I use a Canon, for example, there is actually a bunch of settings in the menu that has two major features: low noise reduction for long exposure, or actual noise reduction itself within the ISO functions. So in other words, there is a long exposure noise reduction feature and also a noise reduction in general built into the camera. Regardless if you shoot RAW, JPEG or anything else, those algorithms are always applied. And that's basically what the Digix processor in this particular camera does, or the X-Trend processor in this, or Sony's processor, or the Z-Series processor. They didn't name it. Sony and Nikon sensors are essentially the same thing. Nikon gets their sensors from Sony. The only difference here is with Nikon's processing is it's done differently. Every camera by default has a predetermined bias and a predetermined dark frame built into them. In other words, the calibration frames are built in to the cameras. You cannot bypass that, you cannot stop that, it'll always do it. Whereas astronomy cameras don't. You have to do that. Now, the big thing here is though, all these mirrorless cameras that I've just showed you, this one, this one, this one, this one, and this one, every single one of these are CMOS cameras. There hasn't been a CCD stills camera for quite some time. In fact, they've just fallen out of fashion, to be totally honest, and they're impractical and they're costly and they're really, really heavy cough Olympus. The idea behind this is these cameras are all CMOS driven as well, but in fact, some of the best Astro cameras out there are actually still and always will be CCD, namely Starlight Express, SBIG, Attic and QSI. All of these higher end, extremely expensive as far as I'm concerned, those cameras are specific for astrophotography purposes. CCD technology, yes, it is old, it is antiquated. However, what you guys may or may not understand is the level of performance and the R&D that has gone into producing the CCD cameras is a lot greater than what you would get with CMOS. Now, prime example, the Trius SX694 from Starlight Express, with their cooling system, actually has the best performance when it comes down to low to no noise. In fact, in terms of noise generation, it is very, very minimal. And more importantly, it's actually uniform to the point where when you stack your frames together, there is not this weird gradient pattern that occurs. With a lot of Canon cameras especially, you get this horrible raining effect that kind of slants downwards. Now you get that with CMOS cameras in general, but Canon has it the worst, which is why PixInsight actually has a setting specifically to remove the banding issues that can occur from Canon cameras. Again, only affects Canon cameras. That's actually not just Canon, so to speak, that's any CMOS sensor can have this problem. 174 or the IMX 174 also has the same issue. So that's why when you're looking at comparing, say, a DSLR camera to an astronomy camera, again, it depends which one, but if you're comparing CCD to DSLR mirrorless, there is no comparison. CCD cameras in general will always beat any of these CMOS cameras. Yes, they are old, yes, they are antiquated, but by our standards, we're not overly fussed about things like that. We want to get a pretty picture. but we don't want to have to work harder than we really need to work for it. Incidentally, you can get these DSLR mirrorless cameras modified, but if you go down that road, you essentially ruin the camera, and that's all it can do. At that particular point, you may as well have the advantage of buying an astronomy-based camera, whether it be QHY or ZWO, and have the cooling capabilities built into it, because it does actually make that big of a difference. For you guys who haven't got a cooled camera, it's a must when you're doing any kind of long exposure. All right. Any other questions? Let's check out if I missed anything here. I don't see anything. If I rabbit on a bit too much, just say something. I tend to talk for pretty much everybody. There's people walking in and out of the store. It's crazy today. Not here. All right, so I take it no more questions from you then. Appreciate you watching it at the very least. No questions. All right, Kevin. No problem. Appreciate you being here, though. So we got a couple of more minutes left. Probably, what, 3 minutes left. What can we talk about? Oh, you know what I should really mention before, if you are thinking about doing a mirrorless camera at some point, I think it goes on until the end of this month. Let me double check. Go to our trusty website to get the latest pricing. So the Canon M100, just so you guys know, there is currently a rebate of $200, so you can actually get a Canon M100 for only $399, which is an incredible price. It's basically the smaller version of this guy. Very, very similar performance. The major difference here is it doesn't do 4K. That's the big deal about it. But $400, you've got yourself a really good astro imaging camera. What do you consider as a very long exposure when needed cooling? Anything above 30 seconds, believe it or not. Once you get into that realm of like long exposure, the sensor itself is what heats up. That's what you've got to keep cool. You're not keeping it cool so it doesn't burn out or anything like that. But what actually happens here, and this has been proven several times, the longer the sensor stays turned on from an electrode charge, the more likely it is to develop noise. In other words, like random noise readout, so to speak. What happens here is the idea of cooling it down is not to actually cool it down, it's to keep the noise consistent. So when you actually do the noise calibration part, in other words, your dark and your bias, it actually calibrates out really nicely. That's why Canon actually has a problem with some of the calibration process, because the way that the mechanical shutter closes, if you're wondering what the mechanical shutter looks like, you can actually see it. You can, let's see if I can catch the light. These are actually shutters here, and they're mechanical. What happens here is that banding actually attracts heat and actually gets stuck on there. So the problem with all of that is, as that warms up, it retains the heat, and that really does come across. I just saw something there. What about cooled CMOS like ZWO? Cooled CMOS ZWOs, they are probably the staple, same with QHY. To me, CMOS cooled cameras from ZWO, doesn't make any difference which one. They're great for beginners, they're fantastic in the intermediate realm, but for the advanced shooters, they kind of lack a little bit of something, and they can be quite instinctively noisy. Again, if you check out my Instagram page, you can see some of the pictures that I've been posting recently with a CCD camera. I will be doing a full video. I've just been collecting a lot of data at the moment. It's just been such bad weather. In fact, this whole year has just been disastrous. It doesn't make any difference what I've been doing, solar astronomy, nighttime photography, whatever. It's just been, cloudy, windy, or whatever the case may be. But you can actually see there is a clear difference when it comes down to cameras like ZWO versus any other CCD camera. And there's no such thing as a cheap CCD camera, unfortunately. What was that other question that I just saw? I don't own a DSLR, only a 290 planetary camera, so all this info for is really good. James, I would say if you are considering about buying a camera, this is why I picked mirrorless. Consider mirrorless over DSLR before anything else. One, the weight capacity. DSLRs tend to weigh a lot more than a regular mirrorless camera, depending on which one you get. Generally speaking, with mirrorless cameras, you actually get more bang for your buck these days because they are trying to sell them. They do want the market to move to them. That's why they offer such great attractive pricing. They have really, really good features that other DSLRs don't have. And one of the biggest disadvantages over having a mechanical shutter within the DSLR, as in that physical mirror box flapping up and down, actually causes vibration, which can be quite a problem because when it opens up, you know, you've got that second or two of oscillation, and if you're doing a short exposure on a very, very bright object, it's really obvious. Obviously longer exposures is not so bad if you're doing, like, say, a 5-minute exposure, because by the time you get to that point, whatever it is, it's pretty much gone anyway. But it does become noticeable and you do have to wait for it to settle down. It's more evident if you're using a flimsy tripod. You really feel it, you really do see it, and it is annoying. Most DSLR cameras do have a mirror lock feature, but what happens here is, especially with Canon cameras, they have a curtain shutter which is still mechanical. Something still flops back down like I just showed a minute ago. The Nikon ones don't have that, they just straight up do electronic shutter. Fuji has a mixture of both. They have both mechanical and electronic. Although in electronic functions, there are a couple of drawbacks here and there, but it is what it is. Modern technology is getting up there. All right, so we're pretty much coming up to wrapping this. Be on the lookout for some of the bigger videos that we do. You know, we do the pre-recorded videos. So like I said, the one that I'm working on right now is actually quite a big one, or it's going to be a big one for me anyway, is CCD versus CMOS cameras. The reasons why you would choose one over the other, the pros and cons, and when to and when not to use certain things. So be on the lookout for that video. It will probably be about another month out because I've only just started to be able to get into doing it because we've just had nothing but hideous weather. And of course, you know, going into this crazy heat wave. So if you've got any more questions, feel free to leave them in the comments below. You can email us or you can email me directly, simon@telescopes.net. You can also give us a call. The number is 888-427-8766. And of course, you can look at our Instagram. If you Google search Wooden Hills Camera and Telescope for our Instagram, you can find that. You can find my personal Instagram, Simon2940, and I hope to see you on the next video. I'll be doing these ones pretty much every Friday, and yes, thank you for mentioning this. I will give you guys a heads up at least a day in advance next time. It's just been, we're trying to test this platform. We're trying to figure out which one works. Daniel does the Facebook Live things, so we're not sure which one we're going to go with. We just have to gauge it and just do the best we can. So thank you very much. I will see you the next time, but all our other videos will always be on YouTube. And yeah, have a great weekend. If you guys are not doing anything, it's good weather. We've got the new moon. For people who are looking at the black moon, you guys are, you know, you're looking at a black moon in a black sky. There was no moon. That's why it's called a new moon. So